Okay, so in the last presentation, the last thing we looked at is how you could trace out a line or a function that finds a firm's total cost for different levels of output. So we were just looking, or at least I was just looking at a graph that looked like this. This is a firm producing more and more units. So they expanded from point A to point B to point C. And at each of those output levels, you could find the amount of labor and capital they should use. And then that would tell you your costs. We're going to skip over how you go from this graph to actually get a total cost function. That's a little bit beyond what we're going to do in this course. So we're going to start from a point where you're given a total cost function. In a cost function, we tell you the quantity that the firm is going to produce, and the output of the function is how much it costs to produce that amount. So let's go ahead and take a look at that. So the goal of firms is to maximize their profits, and profits are revenue minus cost. So knowing the cost function is good. So let's say that here's a firm. This is a total cost function. The equation is given here, and the graph is on the left. Let's go ahead, and I want you to fill in this table right here. For each quantity, go ahead and fill in what the total cost is going to be. So you just take the quantity and you plug it in here. So go ahead and figure out what the entries in this table should be, throw them in PlayPosit, and then we'll go from there. Okay, so here is the filled in table. If I produce 1 unit, my total cost is $8. If I produce 2 units, my total cost is $12.50, and so on and so forth. Okay, so now let's say that we know that the market price for the good I'm producing is $6. How do I decide as the owner of this business what my output level should be if I want to maximize my profits? We can assume that no matter how many units I put out there, they'll be bought. So does it make sense for me to produce 1,000 units? Would that maximize my profit? And the answer is no. So, let's think about what would happen here. So the market price, so my total cost when I produce 1 unit is $8. To produce the second unit, I am going to increase my cost by $4.50. So to go from my first unit to my second unit, I increase my cost by $4.50. Well, how much extra money did I bring in from making that second unit? Well, the market price is $6, and I sold it, which means that when I sold that second unit, I made a profit on it of $1.50 because it only cost me an extra $4.50 to produce, but then I sold it for $6. So that's pretty good for me. When I go from producing 2 units to the third unit, I go from a total cost of $12.50 to a total cost of $18. Here my total cost increased by $5.50. Was it worthwhile for me to produce that third unit? Yes, because even though it cost me $5.50 more to make, I was able to sell it for $6. So that's good. I made a profit of 50 cents on the third unit. When I go to make the fourth unit of this good, my costs increase by $6.50. If I try to sell that, I can only get $6 for it in the market. So I will have lost 50 cents if I produce that. So I do not want to produce the fourth unit because I'm going to take a loss when I try to go to sell it. So I will produce up to 3 units and then stop there. So 3 units is my profit maximizing amount of output. This number that I was computing over here, the additional cost of each additional unit, That's called the marginal cost. So given the amount of output I'm producing now, what will the next unit cost me to produce? So it should be no surprise that if we know total cost, the way we go, so here's the table all filled in. Same conclusion, the firm should produce 3 units because the 4th unit you start to take a loss. Let's look at a way to do this without having to make a table, because the table's cute, but it takes a while and you have to fill it in, and why do I need to fill in 10 numbers when I'm looking for one exactly? So just some vocabulary. Marginal revenue is the amount of money you make, the amount of money you bring in from selling the next unit. So in the case that we were looking at, marginal revenue is very simple. It's just the price. The market price is out there. As a firm in this industry, we're assuming that I can't affect the market price. It's just established out there. Nothing I do affects the market price. So that's just sort of a given. No matter how many units I produce, whether it's my first unit or my 10th unit, I'm going to get the same price out on the market. In the example we just did, the marginal revenue was $6 because that was the market price. So marginal revenue always means the amount of money you will make off of the next unit you produce. The amount that your total cost increases when you produce the next unit is the marginal cost. So that was the column of prices I was writing in on the example. So however much your cost goes up when you produce the next unit, that's your marginal cost. So to maximize profit, so this is a key rule in economics. I want to produce an output level where my marginal revenue is exactly equal to my marginal cost. So as you saw in the example, the more I produce, the higher my marginal cost gets. It becomes more and more costly to produce more quantity. My marginal revenue was staying even at 6. As long as the next unit costs less to produce than the amount of money I can get for it on the market, I want to go ahead and produce it. So if I can make a profit on that next unit, I want to produce it. If the next unit is going to cost more than the amount of money I can get on the market, I don't want to produce it because I'm going to take a loss on it. So we want to try to find that quantity where marginal revenue is exactly equal to marginal cost, because that will mean that I have made a profit on all of the units I produced up until then. And I want to stop when the cost of producing the next unit is exactly equal to the revenue I'd make for it. So mathematically, let's look at how to do that. Okay, so in order to go from a total blank function to a marginal blank function, we always apply the power rule. We've seen this many times already in this course. To go from utility to marginal utility, we apply the power rule. Whether that's the marginal utility from good X or from good Y. When we were looking at isoquants recently, to get the marginal product of labor, you apply the power rule with respect to labor, blah, blah, blah. So in general, if we want to go from total cost to a marginal cost, we're going to apply the power rule to the total cost function. So in our example, we were given a total cost function here. When you apply the power rule, bring down the 2 right here, and then subtract 1. And then the next term here, the exponent on the q is 1. If you bring that down, you just get 3, and the q disappears. 4.5 is a constant, so that goes to 0 when you apply the power rule. So you get the marginal cost is equal to 2 times 0.5 is 1. 2 minus 1 is 1. So this first term is just q plus 3. So marginal cost, in our case, is q plus 3. Our marginal revenue was just the market price, 6. So to find the profit maximizing output, we just set marginal revenue equal to marginal cost, 6 equals q plus 3, and you get that the optimal output quantity, q star, is in fact 3. Easy. think you might have an example problem on the next slide. Sure do. So go ahead. I want you to figure out what is the optimal output level for this firm, and then how much is their profit going to be at that output level. So I'm going to go ahead and pause it and put up the work. I want you to work it out and put your answer in play, pause it, and we'll see how it goes. Okay, so to find the profit maximizing quantity, I want to find the marginal cost. So that's what I did first over here. Took the derivative of total cost with respect to quantity. You get 6Q minus 5 when you apply the power rule. Marginal revenue is just equal to the market price. In the problem, we're told that's $37. So here I set marginal revenue equal to marginal cost. When you solve for Q, you get that the profit maximizing quantity is 7. So I want to produce 7 units. So the second part of the question was to find out how much profit the firm makes when they produce 7 units. So remember, profit is equal to revenue minus cost. So I'm going to figure out revenue. I'm going to figure out cost. I'm going to subtract. Revenue is just $37 per unit that you make, and we're going to make 7 units. So 37 times 7, we're going to bring in $259. To figure out the cost, I'm going to plug in 7, because that's how many units I'm going to make, into the total cost function. So you plug into the total cost function up there, get 3 times 7 squared minus 5 times 7 plus 5. When you work that out, you get that costs are $117. So to figure out profit, I made $259 in revenue. My costs were $117, so my profit is going to be $142. And that is the maximum profit this firm can make, given this market price and their cost function. So we can also have thought about this problem graphically and solved it that way. I have graphed the marginal cost function here, 6Q minus 5. So that's what the red line is right here. And then the market price was 37. And so the quantity at that point of intersection is 7 units. So again, if you know the functions, you can set them equal and find the intersection graphically, or you can solve it algebraically like we did there. You're still going to, once you know that Q star is 7, you're still going to have to go back and plug that in to find the amount of profit they make using the same process we did before. All right, so that's it for now. I will talk to you all soon. Thanks for listening.